Hi there. We are now at subtopic work and energy. Here, we will discuss the relation between work done to energy of the object being moved, called the mechanical energy. Mechanical energy consists of two types of energy, that is the kinetic energy and the potential energy. This subtopic will include definition of energy, work and kinetic energy, work and potential energy, and the principle of conservation of mechanical energy. Definition of energy. Energy is defined as the ability to do work. Energy has different forms, such as mechanical energy, chemical energy, and electrical energy. Energy cannot be destroyed, but can be changed from one form to another. Kinetic energy of an object is the energy it possesses because of its motion. Any mass, m, that is moving with a velocity, v, is said to have kinetic energy. The equation for kinetic energy is 1/2 times the mass, m, times the square of velocity, v. Work energy theorem. This theorem connects the total work done with the change in kinetic energy of the object. Work energy theorem tells us that the total work done on an object by the net force acting on it is equal to the change of kinetic energy of the object. The equation for work energy theorem is derived from the equation for total work done. Total work done equals the final kinetic energy minus the initial kinetic energy. Let's look at the following example. How large a force is required to accelerate a 1,300 kilograms pickup truck from rest to a velocity of 20 meters per second in a distance of 80 meters? Determine the acceleration of the truck. For this problem, no information is given on the forces that act to move the truck. The informations given are the mass and the velocities of the truck. To calculate total work done, the work energy theorem must be used. The total work done is 260,000 joule. From the total work done, the net force acting on the truck can be calculated. And is found to be 3,250 newtons. From the Newton's second law, the acceleration of the truck can be calculated. The truck is accelerated at 2.5 meters per second square. Work and potential energy. Gravitational potential energy of an object is the energy it possesses due to its height from the Earth's surface. Any mass, m, at a height, h, from the Earth's surface has potential energy given by m, mass, times g, the gravitational acceleration, times height, h. Work done against gravitational force to lift an object through a height, delta h, is negative m, times g, times delta h. Work done by gravitational force to bring down an object through a height, delta h, is m, times g, times delta h. Let's discuss the principle of conservation of mechanical energy. Mechanical energy of a system is kinetic energy plus potential energy. force that does work has two types: conservative force, non-conservative force. A force is conservative if work done by the force depends only on the initial and final positions of the object. The amount of work is not dependent on the path taken to move the object from the initial to the final position. From the above diagram, if an object is moved from A to B by a conservative force, work done along path 1, path 2, and path 3 is the same. If an object is moved from A to B by a non-conservative force, work done along each of the paths will be different. Work done by a conservative force does not contribute to the increase or decrease in total mechanical energy of the object. Total work done by conservative forces is zero. Work done by a conservative force, WC, equals delta KE, or negative delta PE. Example of conservative force is gravitational force. Work done by a non-conservative force will result in change in total mechanical energy of the object. Total work done by non-conservative forces equals the change in energy, delta E. Work done by a non-conservative force equals the change in kinetic energy, delta KE, plus change in potential energy, delta PE. Example of non-conservative force is friction force. Let's look at the following example on conservation of mechanical energy. Example 1, work done by conservative force. A 40-gram marble falls through a vertical distance of 25 centimeters from a tabletop to the ground. Calculate A, the kinetic energy, B, the velocity of the marble just before it hits the ground. As the marble falls, the only force acting on it is the gravitational force, mg. Since gravitational force is a conservative force, change in kinetic energy, delta KE, plus change in potential energy, delta PE, equals 0. The potential energy of the marble, due to its position, is converted to kinetic energy of 0.098 joule. The velocity of the marble, just before it hits the ground, is 2.21 meter per second. Example 2. Work done by non-conservative force. A 55 kilograms box, with initial velocity of 0.45 meter per second, slides down a ramp, inclined at an angle of 23 degrees, with the horizontal. If the coefficient of friction between the box and the ramp is 0.24, how fast will the box move after it traveled 2.1 meters down the ramp? The box is acted on by the gravitational force and the friction force between the surfaces of the box and the ramp. This is because only the gravitational force and the friction force has components along the displacement of the box. This is shown in the free body diagram of the box. Work is done on the object only by the friction force, since friction force is a non-conservative force. Work done by friction force equals the change in kinetic energy, delta KE, plus the change in potential energy, delta PE. Proceed to obtain the equations for work done by friction, the change in kinetic energy, and the change in potential energy. Substitute equation 2, 3, and 4 into equation 1. The velocity of the box is determined to be 2.7 meters per second.